What if you stepped outside tomorrow morning and saw not one, but two suns rising over the horizon, or walked along a shoreline where the waves crashed in slow motion under the glow of an enormous red star? The universe is teeming with worlds so strange, so breathtakingly alien, yet some of them share something extraordinary with our own planet, conditions where life, just maybe, could find a way. Picture oceans swirling under hazy orange skies, towering ice formations glittering under distant starlight, or vast plains where the air itself might feel eerily familiar. These aren't scenes from science fiction, they're real places, real possibilities, waiting light years away among the stars. For centuries, we've wondered if we're alone in the cosmos, but today, thanks to cutting-edge telescopes and tireless astronomers, we're closer than ever to answering that question. Hidden in the data from distant star systems are clues: planets with the right temperatures, the right chemistry, even the right ingredients for life as we know it. Some orbit in the perfect zone where water could flow freely. Others have atmospheres thick with gases that hint at something stirring beneath the clouds. And a few might even be more Earth-like than we ever dared to hope. These worlds aren't just dots on a map, they're invitations to imagine, to explore, to rethink what's possible beyond our solar system. That's exactly what we're about to do. In this journey across the cosmos, we'll uncover 25 alien planets where the conditions are so surprisingly Earth-like, they'll make you question everything you thought you knew about life in the universe. From molten super-Earths with skies full of metal vapor to watery worlds where continents might be carved by endless tides, each of these discoveries tells a story about resilience, about chance, and about the incredible diversity of planets scattered like jewels across the galaxy. So buckle up, whether you're a seasoned space enthusiast or just curious about what's out there, you're about to see our universe in a whole new light. The search for another Earth isn't just science, it's a glimpse into the future, and it starts right now. Imagine a world not too different from our own, quietly orbiting a faint red sun 500 light-years away. Kepler 186f isn't just another exoplanet, it's a tantalizing glimpse of what another Earth might look like. Slightly larger than our home planet, this rocky world sits snugly in its star's habitable zone, where temperatures could allow liquid water to pool on its surface. That's the magic word water, the ingredient that makes life as we know it possible. And here's what's truly remarkable. Kepler 186f doesn't just orbit in the right place. It feels familiar. Its red dwarf sun, cooler and smaller than ours, bathes the planet in a perpetual amber glow like an eternal sunset. Days here would be dimmer than on Earth, but not darker, just softened as if filtered through stained glass. Scientists believe its year lasts about 130 Earth days, a gentle rhythm shaped by its close but careful dance with its star. And unlike many exoplanets that suffer extreme tidal locking, where one side always faces the sun while the other freezes in darkness, Kepler 186f might just have something Earth-like, a rotation. That means it could have days and nights, seasons, even weather patterns. But what really sparks the imagination is what we can't see yet. Telescopes hint at a rocky composition, possibly with iron cores and silicate mantles just like Earth's. If there are mountains, they might scrape thin, nitrogen-rich skies. If there are oceans, their waves could lap against shores under that muted crimson light. And while its star flares more violently than our sun, any potential life might have adapted, sheltering under thick atmospheres or even underground. Here's the kicker: Kepler 186f isn't young. It's older than our solar system. That means if life ever took hold here, it's had billions of years to evolve, to experiment, to thrive in ways we can barely fathom. It's a time capsule, a world that might hold answers to questions we're only beginning to ask. For now, it's just a blip in telescope data, a shadow crossing a distant star. But in that shadow, there's wonder, because if a planet like this exists, how many others are waiting? And if one of them is this close to feeling like home, what does that say about the universe's appetite for life? Just 4.2 light-years away, practically our cosmic backyard, Proxima Centauri b orbits the faint red glow of its parent star, the closest exoplanet we've ever discovered. Imagine stepping outside to a sky dominated by a dim, crimson orb 3 times larger than our sun appears, hanging motionless in a perpetual twilight. This world doesn't just feel alien, it defies Earth-like expectations in ways that challenge everything we thought we knew about habitable zones. Locked in an orbit 20 times closer to its star than Earth is to the Sun, Proxima Centauri b completes a full year in just 11 Earth days. But here's the twist, that proximity doesn't mean scorching heat. Its star, Proxima Centauri, is a red dwarf, so cool and faint that even snug and tight, the planet basks in temperatures that could allow liquid water. That's the dream, right, but the reality is far stranger. Tidal locking is the elephant in the room. Many astronomers think one side of this planet forever faces its star, bathed in eternal sunset hues, while the other side languishes in frozen darkness. A razor-thin twilight ring might be the only place where conditions are just right, a Goldilocks strip sandwiched between fire and ice. Yet life, if it exists here, might not play by our rules. Picture vast, sluggish oceans on the sunlit side, churning heat toward the dark hemisphere, or subterranean ecosystems thriving in the perpetual stability of underground caves, shielded from the storms raging above. And those storms are no joke. Red dwarfs like Proxima Centauri are notorious for violent flares, blasting their planets with radiation surges hundreds of times stronger than anything Earth experiences. An atmosphere here would need to be a fortress, or maybe life wouldn't need one at all. Some theories suggest organisms could evolve in shielded layers of ice or even in the airless cracks of rocks, metabolizing cosmic rays like energy drinks. The kicker, Proxima Centauri b is old, ancient even. It's had billions of years longer than Earth to cook up something extraordinary, with next-generation telescopes finally turning their gaze toward this nearby neighbor. We might soon uncover truths that rewrite biology itself. Is it a radiated wasteland, a twilight oasis, or something beyond our wildest theories? One thing's certain. If life does cling to this world, it won't just be a discovery, it'll be a revolution. Now let's travel 39 light-years to a planetary system that redefines the word neighborhood. Nestled around an ultra-cool dwarf star so faint it barely outshines Jupiter, TRAPPIST-1e isn't just another exoplanet. It's part of a cosmic family portrait, 7 roughly Earth-sized worlds, all huddled closer to their star than Mercury orbits our Sun. Yet somehow, against all odds, this particular planet, TRAPPIST-1e, has scientists leaning forward with notebooks open and imaginations racing. What makes it special? Start with the numbers, roughly the same size as Earth with a density that screams rocky world. TRAPPIST-1e occupies the sweet spot in its system's habitable zone. But here's where things get wild. Its star, a dim red ember, gives off just 1/2000th of our Sun's visible light. Walk on its surface and the sky would look like perpetual dusk, the faint star hanging large and dark red overhead, a quiet, brooding presence. Yet despite the gloom, temperatures could allow liquid water, not in vast, churning oceans perhaps, but in sprawling networks of shallow seas, their surfaces shimmering under that eerie glow. The real magic lies in the system's architecture. Those 7 planets orbit so tightly that from TRAPPIST-1e's surface, neighboring worlds would dominate the skyline, some appearing larger than our moon, their cratered faces or swirling atmospheres visible to the naked eye. Imagine standing on an alien beach, watching not 1 but 3 planetary disks rise above the horizon, their phases shifting as they dance through their orbits every few days. It's a celestial ballet we can't see anywhere else in the known universe, but there's a catch. Ultracool dwarfs like TRAPPIST-1 are moody. They frequently erupt with violent flares that could strip atmospheres or drench surfaces in radiation. So how could life survive? The answer might lie beneath. Geological activity could churn protective magnetic fields into existence, or perhaps life huddles in subsurface oceans, shielded by miles of ice, a scenario we've seen working right here in our solar system, beneath Europa's frozen crust. The most tantalizing clue came in 2017 when Hubble spotted hints of water vapor in the system. Not proof, but a whisper, one that next-gen telescopes like James Webb are now racing to decode. Because if TRAPPIST-1e has water, an atmosphere, and this many sibling worlds just a gravitational stone's throw away, well, suddenly the word habitable takes on thrilling new dimensions. Deep in the constellation Cetus, 49 light-years from Earth, a planet named LHS 1140b defies expectations at every turn. This isn't just another super-Earth, it's a cosmic heavyweight with secrets that could rewrite the rules for habitable worlds. Nearly 7 times more massive than our planet, it shouldn't, by conventional logic, be a candidate for life. Yet here it sits, square in the habitable zone of its quiet red dwarf star, teasing astronomers with the possibility of something extraordinary. A thick, nurturing atmosphere clinging to its surface like a protective blanket. What makes this world so special starts with its star. Unlike the violent flares of Proxima Centauri, LHS 1140's sun is calm, almost serene. That stability matters because it gives the planet a fighting chance to hold onto its atmosphere over billions of years. And oh, what an atmosphere it might be. Early observations suggest it could be dense, possibly nitrogen-rich, with layers so thick they'd turn the surface into a pressure cooker. But here's the twist, that very pressure might create a paradoxical oasis. While larger than Earth, LHS 1140b's gravity could compress its atmosphere into a Goldilocks zone at ground level, where temperatures and pressures allow water to stay liquid, even if the skies above are crushing. Then there's the water question. A planet this massive should be a mini Neptune, swaddled in hydrogen and helium gas. But LHS 1140b's density tells a different story. It's rocky, possibly with a gargantuan iron core. That means it could have something Earth-like beneath those skies, vast magma oceans releasing steam, or subterranean reservoirs bubbling up through cracks in a global crust. Some models even suggest it might be a water world, with deep, planet-wide oceans sealed under an ice shell except near the equator, where geothermal heat could thin the ice, creating pockets of open water. The real kicker, this planet is old, ancient even. Red dwarfs burn for trillions of years, and LHS 1140b has likely been sitting in that habitable zone since before Earth formed. If life ever took root here, it's had unimaginable time to adapt, to thick atmospheres, to crushing pressures, to dim crimson sunlight filtering through perpetual haze. Next-generation telescopes are already lining up to study this world's atmosphere for biosignatures, because if a planet this massive, this strange, can cradle life, the universe might be far more generous with its miracles than we ever dreamed. Somewhere in the Lyra constellation, about 1,200 light-years away, a planet named Kepler 442b does something remarkable. It out-Earths Earth. At least when it comes to the magic of sunlight, this isn't just another habitable zone world. It's a rare gem where the very starlight raining down might be better for photosynthesis than what our own plants receive. Picture leaves unfurling under golden skies, basking in wavelengths nearly perfect for turning light into life. Kepler 442b orbits a star slightly smaller and cooler than our Sun. But here's the twist, that star's light spectrum hits a biological sweet spot. Scientists calculate this planet receives about 70% of Earth's solar flux, but the light it does get skews toward the red and infrared, precisely the range where chlorophyll, or any alien equivalent, could work with staggering efficiency. What makes this world even more compelling is its rock-solid stability. Unlike frenetic red dwarf systems where planets endure violent flares, Kepler 442b star is a placid K-type, radiating steady warmth for billions of years. Its orbit is a textbook example of just right, neither too eccentric nor too tense, giving it reliable seasons without extreme temperature swings. And with an Earth Similarity Index score of 0.84, 0.9 is considered an Earth twin. It's one of the closest matches we've found to our own pale blue dot. But the similarities run deeper than numbers. Models suggest a rocky composition with active plate tectonics, possibly recycling nutrients through a dynamic crust. Its gravity, about 30% stronger than Earth's, could foster dense, weather-resistant atmospheres where storms rage less violently than on gas-shrouded worlds. Some theorists even speculate about vast continents. Their shorelines shaped by gentle tides. This planet's larger size might mean shallower oceans, leaving more room for sprawling landmasses ripe for complex ecosystems. Yet the most haunting question lingers in that golden light. If photosynthesis is more efficient here, what might that mean for evolution? Could forests grow taller, their canopies thicker under that optimized glow? Or would life take a different path entirely, evolving pigments we've never imagined to harness those crimson-rich rays? For now, Kepler 442b remains a tantalizing silhouette against its star. But with next-generation telescopes poised to analyze its atmosphere, we might soon learn whether this world isn't just similar to Earth, but in some ways a perfected version of it. For years, astronomers assumed planets like K2-18b were nothing more than gas-shrouded dead ends in the search for life, until this mini-Neptune did the unthinkable. Located 110 light-years away, orbiting a dim red dwarf in the constellation Leo, this world is nearly 9 times Earth's mass and twice its radius, wrapped in a thick hydrogen envelope that should have made it utterly inhospitable. Then came the bombshell, Hubble's detection of water vapor swirling in its atmosphere. Suddenly, the rules of habitability were up for debate. What makes K2-18b so revolutionary isn't just the presence of water, it's the context. Mini-Neptunes, long dismissed as gas dwarfs, were thought to lack solid surfaces, their crushing pressures and deep gaseous layers ruling out any chance for life as we know it. But K2-18b defies the template. Its temperature sits in the habitable zone's sweet spot, and that hydrogen-rich atmosphere, rather than smothering all hope, might act like a cosmic pressure cooker, creating a hidden oasis. Picture this, deep beneath the cloud tops where pressures soar to hundreds of times Earth's, hydrogen transitions into a supercritical fluid, a bizarre state between gas and liquid. Here, temperatures could allow water to exist in a global ocean, not atop rocky continents, but dissolved within this shimmering, fluid layer, an endless glowing sea with no surface or floor. The real shocker, some models suggest organic molecules could survive and even form in these extreme conditions. Microbes on Earth thrive in hydrothermal vents under staggering pressures. Why not here, floating in pockets of that alien ocean? But skeptics push back. Without a traditional surface, could life ever gain a foothold? The energy sources are murky and the chemistry uncharted. Yet K2-18b doesn't care about our doubts. Recent James Webb observations hint at more surprises. Dimethyl sulfide, a gas on Earth produced only by living organisms. It's not proof, but it's a siren call for further study. The implications are staggering. If life can exist in the soupy depths of a mini-Neptune, the galaxy's habitable real estate just exploded. Red dwarfs, the most common stars, host countless worlds like this. K2-18b might be the first clue that we've been looking for life in all the wrong places, and that the universe's creativity outstrips our imagination. One thing's certain, this isn't the last we'll hear from the gas dwarfs. They're rewriting the story of where life could hide, one vapor-laden whisper at a time. Among the countless exoplanets discovered by NASA's TESS mission, one world stands out not just for its Earth-like size, but for the serene balance it maintains in a cosmic tightrope act. TOI 700d, orbiting a small, cool M-dwarf star just 100 light-years away, occupies the kind of real estate astronomers dream of, the habitable zone's sweet spot, where temperatures could allow water to flow without boiling away or freezing solid. But what makes this planet truly mesmerizing is how it dances with its star locked in a gravitational embrace that creates a world of perpetual twilight, where day and night are not cycles but permanent realms. Unlike Earth's leisurely rotation, TOI 700d is tidally locked, one face forever bathed in the dim, reddish glow of its sun, the other shrouded in eternal darkness. At first glance, that might sound like a recipe for extremes, a scorching hemisphere and a frozen wasteland. Yet climate models reveal something astonishing. This world could harbor a twilight belt of remarkable stability. Imagine a band near the Terminator line where the star hovers perpetually on the horizon, casting long shadows across sprawling wetlands or shallow seas. Here, gentle winds might circulate heat from the dayside, preventing the night side from plunging into absolute zero, while high-altitude ice clouds could act like a planetary sunshade, scattering just enough warmth to keep the climate temperate. But the surprises don't stop there. TOI 700d star is unusually quiet for a red dwarf. No violent flares or radiation storms to rip away potential atmospheres. That stability is rare in this cosmic neighborhood, and it gives this planet something priceless: time. Over billions of years, volatiles like water and carbon dioxide could accumulate, creating a thick, nurturing blanket of air. Some simulations even suggest dynamic weather patterns, drizzle softening the dayside deserts, or fog rolling into the twilight zone from the frozen night side, feeding alien ecosystems adapted to the faint ruby light. What's most tantalizing is how ordinary this planet seems in its composition. Roughly 20% larger than Earth, with a likely rocky surface, TOI 700d ticks all the boxes for a world where life could take root. And with tests continuing to monitor its transits, astronomers are racing to decode its atmospheric secrets. If future telescopes detect water vapor, oxygen, or even methane in those skies, this unassuming world could become a cornerstone in our understanding of life's potential, proof that even in the quietest corners of the galaxy, nature finds a way. Hidden in the constellation Hydra, just 31 light-years from Earth, GJ 357d isn't just another super-Earth, it's a paradox wrapped in cosmic irony. Orbiting a star so faint it's barely visible without a telescope, this planet shouldn't be a contender for life at all. Yet here it sits, a hulking world at least 6 times more massive than Earth, perched perfectly in its star's habitable zone. The key lies in its quiet host. Unlike the violent tantrums of Proxima Centauri, GJ 357 is an M-dwarf that barely whispers, its gentle radiation allowing the planet to cling to an atmosphere for billions of years without being stripped away. What makes this world so captivating is its rhythm. While Earth takes 365 days to orbit the Sun, GJ 357d completes its journey in just 55.7 Earth days, a whirlwind year compressed by its snug orbit. But here's the twist: that proximity doesn't mean scorching heat. The star's cool temperament means the planet basks in just enough warmth to possibly host liquid water, despite being 13 times closer to its sun than Mercury is to ours. Walk on its surface and you'd see a dim, cherry-red orb looming large in a perpetual twilight sky, casting long shadows over what could be valleys cradling rivers or glaciers creeping under that muted glow. The real intrigue lies beneath. With gravity nearly twice Earth's, GJ 357d could be a master of disguise. Its thick atmosphere, likely rich in nitrogen or carbon dioxide, might press down with enough force to create subterranean oceans where liquid water hides under ice sheets or within sprawling cave networks. Imagine hydrothermal vents spewing minerals into pitch-black seas, their chemistry ripe for life that evolved without ever seeing the sky. Or picture dense, slow-moving weather systems swirling across continents, their patterns locked in place by the planet's probable tidal locking, where one side always faces the star. Recent studies suggest another tantalizing possibility: volcanic activity. A world this massive could have a churning interior, its tectonic forces releasing enough heat to maintain surface water even without strong sunlight. Add potential geothermal hotspots, and suddenly those dark, frozen regions might harbor oases, steam rising through cracks in the ice, creating microclimates where organisms could cling to survival. The clock is ticking for answers. J357d is ancient, far older than Earth, meaning any life here has had eons to adapt to its strange rhythms. With upcoming telescopes set to probe its atmosphere for biosignatures, this super-Earth might soon reveal whether habitable means more than just the right temperature, whether it can mean a world that bends the rules entirely, proving life thrives not in spite of the extremes but because of them. 600 light-years away, tucked into the Lyra constellation, Kepler 62f doesn't just resemble Earth, it mirrors our world in ways that make astronomers do a double take. Nearly 1.5 times Earth size, this planet orbits a star slightly cooler and smaller than our Sun, but it's the rhythm of that orbit that's truly striking. Every 267 days, Kepler 62f completes a graceful loop around its star, placing it squarely in the habitable zone's sweet spot. Not too close to boil away its oceans, not too far to freeze them solid. Just right, but what really sets this world apart isn't just where it orbits, it's what might be waiting beneath its skies. Kepler 62f's radius suggests a density comparable to Earth's, hinting at a rocky composition with the potential for vast, rolling landscapes. Yet many scientists suspect something even more intriguing. This could be a planet almost entirely shrouded in water. Picture an endless global ocean, deeper than our Pacific, stretching from pole to pole without a single continent breaking the surface. The implications are staggering. Without land masses to absorb heat, ocean currents would dominate the climate, creating weather patterns unlike anything on Earth. Superstorms might rage across those waters, their energy fueled by the planet's stronger gravity. Tides pulled by unseen moons could generate waves taller than skyscrapers. But beneath the chaos, there's potential for tranquility. Thermal vents on the ocean floor, much like Earth's, might foster ecosystems thriving in perpetual darkness, their chemistry fueled by minerals spewing from the planet's core. Here's the twist: Kepler 62f star is older than ours, meaning this planet has had billions of extra years to cook up life. If oceans exist, they've been stable for eons, time enough for evolution to experiment with forms we can't yet imagine. The real question isn't just whether there's water, but what might be swimming in it. Telescopes can't yet peer into those hypothetical depths, but future missions hunting for atmospheric biosignatures could reveal clues. A detection of oxygen here would be explosive, because on a water world, where would it come from if not life? One thing's certain: Kepler 62f challenges our assumptions. A planet doesn't need to be Earth's twin to be habitable. It just needs the right ingredients and time. This world has both. Whether it's an aquatic wonderland or a silent orb of ice, it stands as a testament to the universe's boundless creativity. And if its oceans do hold life, well, that changes everything. 14 light-years away, so close we could practically shout across the void, Wolf 1061c spins in a cosmic dance that defies expectations. This super-Earth, nearly 4 times our planet's mass, doesn't just occupy its star's habitable zone, it teeters on the edge of chaos. The challenge here isn't just distance from its dim red sun, but the wild, elliptical path it takes around it. Imagine a world where seasons aren't gentle transitions, but violent lurches between extremes, where one side of the planet might bake under relentless heat while the other freezes in the star's retreating shadow. Wolf 1061c's orbit is a roller coaster. Unlike Earth's near-circular journey around the Sun, this planet follows a stretched oval path that brings it startlingly close to its star before flinging it back out into the colder reaches. The result, temperature swings that could span hundreds of degrees over the course of a single 60-day year. 1 month, lakes might bubble under scorching skies. The next, they could flash freeze into glaciers. Yet somehow, despite this turbulence, models suggest there's a sweet spot, a Goldilocks scenario where liquid water could persist. The secret might lie in the planet's thick atmosphere if it has one. A dense shroud of greenhouse gases could act like a planetary thermostat, trapping heat during the colder phases and redistributing warmth during the broiling close approaches. But atmospheres around red dwarfs like Wolf 1061 face brutal trials. These stars are notorious for their tantrum solar flares that erupt with enough force to strip away protective gas layers over time. Without a magnetic field strong enough to deflect those attacks, this super-Earth could be left exposed, its skies slowly bleeding into space. Yet there's tantalizing evidence it might be holding on. Observations hint at a rocky composition with a molten core, which could generate the kind of magnetic shield that keeps Earth safe. If that's the case, volcanic activity might even replenish the atmosphere, creating a dynamic equilibrium where loss and renewal balance out. The real question isn't just whether Wolf 1061c could host water. It's what kind of life could endure such brutality. Extremophiles on Earth thrive in acid lakes and deep sea vents, but this planet would demand something more. Organisms that hibernate through deep freezes, then explode into activity during brief thaws. Or perhaps life exists entirely underground, where geothermal heat stabilizes the environment, and the surface is just a forbidding mask. What makes this world so compelling is its proximity. At 14 light-years, it's practically next door in galactic terms, close enough that future telescopes could analyze its atmosphere in unprecedented detail. Imagine detecting methane spikes that coincide with orbital warming, or oxygen patterns that suggest photosynthesis ebbing and flowing with the seasons. Wolf 1061c isn't just a test case for habitability, it's a laboratory for the extremes life can endure. And if anything survives here, it won't just reshape our search for aliens, it'll redefine resilience itself. Kepler 452b isn't just another exoplanet, it's the closest thing we've found to a mirror of our own world, orbiting a star so similar to the Sun, it's uncanny. Located 1,400 light-years away in the constellation Cygnus, this planet has earned its nickname, Earth's cousin, for good reason. Its host star, Kepler 452, is a G-type main sequence star just like ours, glowing with nearly identical temperature and brightness. But here's where things get fascinating. This star is older, 6 billion years old, to be precise 1.5 billion years more seasoned than our Sun. That means Kepler 452b has had an extra eternity to simmer in the conditions that might make life possible. What sets this world apart starts with its rhythm. A year here lasts 385 Earth days, just 20 days longer than our own orbit. That subtle difference places it squarely in the habitable zone's sweet spot, where liquid water could pool on its surface without boiling away or freezing solid. But the real magic lies in its size. At 1.5 times Earth's diameter, gravity would feel roughly twice as strong, shaping everything from mountain ranges to weather patterns. Walk on this planet, and your feet might sink into thick, moss-like vegetation adapted to the pull, while towering cliffs erode slower under the weight of that relentless force. Then there's the tantalizing question of geology. With its extra mass, Kepler 452b likely boasts a molten core churning with tectonic activity. That's a big deal. Volcanoes could be recycling nutrients into the atmosphere, while plate tectonics might craft continents and ocean basins over eons. Some models even suggest sprawling archipelagos dotting shallow seas, their shorelines reshaped by tides under a sun that would look hauntingly familiar, albeit slightly dimmer and redder with age. But the most compelling clue is the planet's longevity. 6 billion years is a staggering span, enough time for life to evolve not just once but through multiple epochs. Imagine forests of towering, photosynthesizing organisms adapted to that older sun's glow, or microbes thriving in geothermal vents that have bubbled relentlessly since before Earth's continents formed. The catch: we can't yet see the surface. Telescopes hint at a rocky composition and a potential atmosphere, but the proof will come when next-generation instruments analyze those skies for water vapor, oxygen, or methane, the chemical fingerprints of activity. Kepler 452b isn't just a scientific curiosity, it's a time machine. Studying this world lets us peer into Earth's possible future as our own sun ages and brightens. If life exists here, it's had a billion-year head start to adapt to changes we've only begun to model. That's the real wonder, not just that we found a cousin, but that it might hold the playbook for survival in an aging universe. Among the pantheon of super-Earths, HD 40307G stands out not for its extremes, but for its eerie sense of equilibrium. Located 42 light-years away in the constellation Pictor, this planet clocks in at roughly 6 times Earth's mass, a heavyweight by most standards. Yet it orbits its orange dwarf star with such precision that temperatures there could mirror a mild spring day on Earth. That's the first clue this isn't just another crushing, high-gravity world. It's a place where the math adds up to something far more tantalizing, a Goldilocks scenario where size doesn't spell doom but opportunity. What makes this world so compelling starts with its star. HD 40307 is a K-type dwarf, slightly cooler and smaller than our Sun, but radiating steadier warmth than the turbulent red dwarfs that dominate planetary discoveries. That stability is a gift. Unlike planets orbiting flare-prone stars, HD 40307G isn't lashed by radiation storms that strip away atmospheres over time. Instead, models suggest it could hold onto a thick, nurturing shroud of gases, possibly nitrogen or carbon dioxide, creating surface pressures high enough to keep water liquid even if temperatures dip. Imagine walking through valleys where the air feels dense like a humid summer evening, the sky tinged orange from the dwarf star's glow overhead, but gravity is the elephant in the room. 6 times Earth's mass means surface gravity nearly twice as strong. On paper, that should make mountains impossible to climb and weather patterns sluggish. Yet there's a twist. The planet's density hints at a composition rich in silicates and iron, much like Earth's core. That's critical because it suggests something Earth-like beneath those skies' active geology. Plate tectonics could be churning beneath the surface, recycling minerals and stabilizing the climate over eons. Volcanic activity might even replenish the atmosphere, balancing any losses to space. The real intrigue lies in the unknown. A planet this massive could harbor vast subterranean oceans, their waters locked under ice sheets or sandwiched between layers of rock. Or it might be a water world with shallow seas sloshing over continental shelves, their waves pulled into strange, elongated shapes by the gravity. Telescopes haven't yet pierced its atmosphere, but future observations could reveal the chemistry of those skies, whether they hold water vapor, methane, or even oxygen. Here's the kicker: HD 40307G is old. Its star has burned steadily for billions of years, giving this planet time, lots of it, to experiment with the ingredients of life. If biology found a foothold here, it's had epochs to adapt to that crushing gravity, that thick air, that amber-lit sky. That's the promise of worlds like this. They don't just expand the habitable zone. They expand our imagination. Sometimes the most extraordinary discoveries happen by accident. Just ask the astronomers who almost missed Kepler 1649c. Buried in old data from NASA's now retired Kepler telescope, this unassuming world was overlooked by algorithms designed to hunt for planets. It took human eyes scanning the numbers to spot what machines had dismissed. An Earth-sized whisper in the cosmos orbiting snugly within its star's habitable zone. Located 300 light-years away in the constellation Cygnus, Kepler 1649c isn't just another exoplanet. It's a cosmic doppelganger, matching our own planet's size with eerie precision while basking in starlight that could make liquid water possible. What sets this world apart starts with the numbers. At just 1.06 times Earth's radius, it's the most Earth-sized planet we've found in a habitable zone around a red dwarf. But here's where things get fascinating. It receives about 75% of the sunlight Earth does, putting its potential surface temperature in the same range as our own planet's subarctic regions. Imagine a world where the air might feel brisk but not frozen, where glaciers could melt into rivers under a dim, ruby-colored sun. The real magic lies in its orbit. Kepler 1649c circles its star every 19.5 Earth days, a rhythm dictated by its tight but carefully measured distance. Unlike many red dwarf systems where planets roast or freeze, this one hits a rare equilibrium. Climate models suggest it could avoid the tidal locking that plagues similar worlds, potentially rotating just enough to distribute heat and maintain day-night cycles. That's critical because without wild temperature swings between hemispheres, the planet might host stable weather patterns, clouds forming over temperate oceans, winds carrying moisture across rocky continents. Yet the star itself poses puzzles. Red dwarfs like Kepler 1649 are notorious for violent flares, but this one seems unusually calm. Observations reveal no major eruptions, at least not yet. If the atmosphere has survived billions of years without being stripped away, it could be rich with gases like nitrogen or carbon dioxide, creating pressures that keep water liquid even under that faint starlight. There's even speculation about geothermal activity. A planet this small should have cooled long ago, but tidal forces from its star might still churn its interior, heating underground reservoirs or fueling volcanic vents. The most tantalizing clue, Kepler 1649c isn't alone. It shares its system with at least one other planet, a rocky neighbor orbiting closer to the star. While that world is likely too hot for life, its presence suggests this corner of the galaxy might be littered with Earth-sized worlds. Future telescopes could analyze Kepler 1649c's atmosphere for biosignatures, hunting for oxygen or methane that might betray the presence of biology. For now, this accidental discovery serves as a reminder. The universe hides its gifts in plain sight. While flashier super-Earths and water worlds grab headlines, it's the quiet, Earth-like planets, the ones that feel almost familiar, that might hold the keys to life's cosmic blueprint. And if Kepler 1649c has been hiding in old data all this time, what else have we missed? 22 light-years from Earth, in the constellation Scorpius, a planet named J667cc defies the very notion of solitude. Unlike Earth's single sun, this world orbits one star in a triple star system, a cosmic trifecta where three suns dance overhead, casting tangled shadows across its surface. The primary star, J667c, is a dim red dwarf, but the real spectacle comes from its companions, two additional stars swirling through the system, their gravitational waltz creating a sky unlike anything we've ever seen. Picture standing on this planet, looking up to witness 3 points of light, one crimson, the others pale orange, painting the clouds in shifting hues as they drift across the heavens. But J667c's allure isn't just its stellar entourage. At roughly 3.8 times Earth's mass, it's a super-Earth with gravity strong enough to sculpt landscapes into dramatic, towering formations. Yet its most tantalizing feature lies in its orbit, snug in the habitable zone where temperatures could allow liquid water. Here's where things get fascinating. The planet's tight embrace with its cool red dwarf means it completes a full orbit in just 28 Earth days. That proximity should make it a roasted wasteland, except the star's feeble heat creates a paradoxical equilibrium. Surface temperatures might hover around 0 degrees Celsius, chilly but not frozen. The real wild card, that triple star gravity. While the primary star holds GJ667cc close, the other two stars orbit farther out, their combined pull potentially stabilizing the planet's climate over eons. Some models suggest their influence could even prevent tidal locking, giving the planet a slow but crucial rotation to distribute warmth. And then there's the greenhouse factor. With a likely thick atmosphere rich in carbon dioxide or methane, this world might trap heat far more efficiently than Earth. Imagine a global greenhouse where the air itself acts like an insulating blanket, compensating for the dim starlight and keeping temperatures just right for liquid water, or even sprawling, algae-choked seas. Yet challenges loom. Red dwarfs are notorious for violent flares, and GJ667c is no exception. Without a robust magnetic field, the planet's atmosphere could be slowly eroding under those stellar storms. But hope lingers in the chemistry. Observations hint at a rocky composition with possible volcanic activity, which might replenish lost gases over time. And if life ever took root here, it's had billions of years to adapt to the faint light, the shifting skies, the occasional radiation blast. What makes GJ667cc so captivating isn't just its potential to host life. It's a test case for resilience, proving that even in chaotic stellar neighborhoods, nature finds a way. Future telescopes could decode its atmospheric secrets, searching for traces of oxygen or methane chemical signatures that might reveal whether this triple-sun world is a cosmic oddity or a beacon of possibility. One thing's certain, in the search for habitable planets, GJ667cc reminds us that the rules aren't just meant to be followed. Sometimes they're meant to be rewritten. Ross 128b hides a quiet miracle in its cosmic corner. Just 11 light-years from Earth, this unassuming world orbits a red dwarf so peaceful it breaks all the rules. While most stars of its type unleash devastating flares that scorch nearby planets, Ross 128 simmers with rare tranquility, making its Earth-sized companion one of the safest bets for life in a red dwarf system. The numbers tell a compelling story: an equilibrium temperature eerily similar to Earth's, an orbit placing it squarely in the habitable zone, and a star that behaves more like a gentle ember than a wildfire. What sets this planet apart isn't just where it sits, it's how it sits there. Ross 128b completes a full orbit every 9.9 Earth days, a tight embrace that would typically spell doom under a red dwarf's wrath. But this star doesn't rage. Observations reveal no significant flares, no radiation spikes, just a steady glow that's allowed the planet to potentially hold onto an atmosphere for billions of years. Walk on its surface and the sky might glow a deep maroon, the star appearing larger than our sun but casting only a fraction of the light, like twilight frozen in time. Then there's the climate puzzle. Tidal locking likely keeps one hemisphere perpetually daylit, the other shrouded in endless night. Yet models suggest something surprising. A thick atmosphere could distribute heat efficiently, creating a twilight belt where temperatures hover near melting ice. Imagine sprawling wetlands along the Terminator line, where sluggish rivers flow under that crimson sky, fed by glacial melt from the night side. Or perhaps geothermal vents dot the dark hemisphere, their warmth creating oases in the frozen expanse, a scenario we've seen work in Antarctica's icy caves. The real hope lies in chemistry. Ross 128 is rich in metals, hinting that its planets might be too loaded with magnesium and iron to fuel volcanic activity or even magnetic fields. Combined with the star's calm demeanor, this raises the odds of stable liquid water. Next-gen telescopes could soon scan its atmosphere for water vapor or methane, but here's the kicker. At just 11 light-years away, Ross 128b isn't just a candidate for life. It's a candidate for contact. Future probes could reach it within centuries, making this tranquil world more than a scientific curiosity. It's humanity's potential next-door neighbor in the cosmos. 270 light-years from Earth, in the constellation Cygnus, Kepler 1229b circles its dim red sun with the patience of a world that knows time is on its side. This rocky super-Earth, roughly 1.5 times the size of our planet, has carved out an existence in one of the cosmos' most paradoxical places, the habitable zone of a red dwarf star, where the rules for survival rewrite themselves. What makes this world extraordinary isn't just its size or location, but the delicate balance it strikes between scorching and freezing, between atmosphere and vacuum, in an environment most astronomers once dismissed as hopeless for life. The rhythm of Kepler 1229b's orbit is a study in precision. Every 86 Earth days, it completes a full loop around its star, close enough to bask in warmth, but not so near that its oceans boil away. Here's the catch: that star emits less than 5% of our sun's visible light, casting the planet in a perpetual crimson haze. Yet beneath that eerie glow, something remarkable could be happening. Climate models suggest its thicker atmosphere, likely rich in greenhouse gases like carbon dioxide, acts like a planetary thermostat, trapping just enough heat to compensate for the feeble starlight. Picture vast, shallow seas tinged red by the sky above, their surfaces rippling under winds that carry warmth from the sunlit side to the frozen darkness beyond. Because like most planets orbiting red dwarfs, Kepler 1229b is probably tidally locked. One hemisphere forever faces its star, baked in eternal twilight, while the other languishes in an endless ice age. But between these extremes lies possibility. The Terminator line, the razor-thin border between day and night, could host a band of temperate stability, where glaciers melt into rivers under that dim, ruby sun. Or perhaps underground aquifers thrive, shielded from surface radiation by layers of rock and ice, their depths warmed by the planet's own geothermal heartbeat. The real magic lies in the star's longevity. Red dwarfs burn for trillions of years, and Kepler 1229b has likely been sitting in this habitable zone since before Earth's continents formed. That's an unimaginable span, time enough for life to arise, vanish, and rise again in countless iterations. If microbes took root here billions of years ago, they've had epochs to adapt to the star's quirks, its faint light, its occasional flares, the gravitational squeeze of tidal forces. But the greatest surprise came when researchers analyzed the planet's reflectance. Kepler 1229b appears darker than expected, a clue that its surface might be soaked in liquid water or covered in vast, light-absorbing forests of alien vegetation. Of course, that's speculation. What isn't speculative is this world's staying power. While Earth's oceans will boil away in 1 billion years as our sun ages, Kepler 1229b's story is just beginning. It's a testament to the universe's stubborn creativity. A planet that shouldn't work in a place that shouldn't thrive, yet somehow defies the odds, and if life exists here, it won't just change our search for aliens, it'll redefine what habitable even means. 12 light-years away, tucked into the faint constellation Aries, Teegarden's star B doesn't just orbit in the habitable zone, it defines it. This unassuming world, barely larger than Earth, circles one of the smallest and oldest stars we've ever discovered. A dim red dwarf so feeble, it wasn't even spotted until 1999. Yet what Teegarden's star lacks in brilliance, it makes up for in cosmic hospitality. The planet's equilibrium temperature mirrors Earth's almost exactly, a rare feat in the exoplanet catalog. But here's the twist: it achieves this without basking in anything resembling sunlight as we know it. Teegarden's star is a ghost of a sun, just 8% the mass of our own, glowing at a temperature barely above 2000 degrees Celsius. From the planet's surface, the star would appear as a dull, cherry-colored ember, casting about as much light as Earth's sunset on an overcast day. Yet this feeble glow hides a paradox. While Tigodon star B receives less than 5% of Earth's solar energy, its snug orbit, completing a year in just 4.9 Earth days, positions it so perfectly that surface temperatures could hover near 0 degrees Celsius. That's cold by human standards, but well within the range where liquid water might persist, especially beneath ice sheets or in geothermal oases. The real marvel lies in stability. Red dwarfs like Tigodon star are infamous for their tantrum solar flares capable of stripping atmospheres within centuries. Yet this particular star is shockingly serene. Observations reveal minimal flare activity, meaning any atmosphere Tigodon star B possesses might have clung on for billions of years, slowly thickening with volcanic outgassing or comet impact. Combine that with the star's absurd longevity, it's likely twice as old as our solar system, and you've got a planet that's had eternity to experiment with chemistry. Then there's the tidal locking question. Most planets this close to their stars are frozen on one side, scorched on the other, but Tigodon star B might defy the norm. Some models suggest its thick atmosphere, possibly rich in greenhouse gases, could redistribute heat efficiently, creating a twilight belt where temperatures are just right for liquid water. Picture sprawling tundras near the Terminator line, their soils warmed by underground geothermal vents, while the sunlit side hosts shallow, briny seas kept from boiling by the sheer weight of the air above. But the most tantalizing clue lies in what we can't see yet. Next-generation telescopes could soon analyze this planet's atmosphere for water vapor or methane. If they find it, Tigodon star B won't just be another habitable zone curiosity, it'll be proof that life's ingredients can persist in the quietest, darkest corners of the galaxy. After all, if a world this dim, this ancient, can hold onto the conditions for life, what does that say about the universe's generosity? Maybe the recipe for habitability isn't about stellar brilliance at all. Maybe it's about patience. Kepler 283c sits in the constellation Cygnus, a staggering 1,700 light-years from Earth, yet it holds a position so perfect it could rewrite our understanding of alien oceans. This super-Earth, nearly 2 times our planet's size, orbits a star slightly smaller and cooler than the Sun, but its real claim to fame is its orbit. Every 93 Earth days, Kepler 283c completes a loop that places it squarely in the habitable zone's sweet spot, where temperatures could allow liquid water to pool across its surface. Not too close to boil it all away, not too far to freeze it solid, just right, but it's the planet's size that sparks both excitement and skepticism. At nearly double Earth's radius, gravity here would feel crushingly intense, roughly twice what we experience. Mountains would wear down faster under that relentless pull, and any potential oceans might cling to shallow basins, their waves sluggish under the weight of the thick, dense air. Yet that very size could be its saving grace. A planet this massive likely boasts a molten core churning with geological activity, fueling volcanic outgassing that replenishes its atmosphere over time. Picture vast plains of basaltic rock, steam rising from geothermal vents, and skies thick with water vapor trapped by the planet's own gravitational grip. The real challenge isn't imagining what Kepler 283c could be, it's proving it. At this distance, even our most powerful telescopes struggle to pierce its atmosphere. Detecting water vapor or oxygen signatures would require planetary alignments so precise they're like threading a cosmic needle. And there's another complication, its star's temperament. While quieter than many red dwarfs, Kepler 283 still unleashes occasional flares, potentially stripping away fragile atmospheres over eons. If this planet has managed to hold onto its air, it's likely thanks to that formidable gravity or a robust magnetic field, something we can't yet measure from Earth. Yet hope lingers in the shadows. Kepler 283 sees larger size means any atmosphere would be more extended, making it slightly easier to study than smaller Earth-like worlds. Future telescopes might catch the faint fingerprint of water or methane in its skies, hinting at active hydrology or even biology. But until then, this planet remains a tantalizing what-if, a reminder that the universe doesn't just create Earth twins. Sometimes it builds something bigger, stranger, and just as capable of cradling life in the unlikeliest of forms. Captain B isn't just an exoplanet, it's a cosmic relic, a survivor from the universe's violent infancy. Orbiting a dim red dwarf 13 light-years away, this world is almost unthinkably ancient, 11 billion years old, more than twice the age of Earth. That means it formed when the Milky Way itself was still taking shape amidst the chaos of early galaxy collisions. Picture a planet that witnessed the birth and death of countless stars before our sun even ignited. Yet somehow, against all odds, Captain B didn't just endure, it found itself parked in its star's habitable zone, where liquid water might still cling to its surface today. What makes this world so extraordinary isn't just its age, but its journey. Astronomers believe Captain B wasn't born around its current star, it was stolen. Billions of years ago, it likely orbited a different sun in a dwarf galaxy swallowed by the Milky Way, a cosmic refugee flung into a new orbit by gravitational turmoil. That violent past raises spine-tingling questions. If life ever took root here, could it have survived the upheaval? Today, Captain B's star is a quiet, cool ember, but the planet's position is precarious. It skirts the outer edge of the habitable zone, receiving just enough warmth to keep water liquid, if it has a thick enough atmosphere to trap heat, and that's a big if. Over 11 billion years, stellar flares and cosmic radiation could have stripped away its protective gases, leaving it a frozen husk. Yet there's a tantalizing counterpoint. Red dwarfs this old often mellow with age, their eruptions becoming rarer. If Captain's star settled down early enough, the planet might have held onto a dense shroud of greenhouse gases, turning its surface into a high-pressure greenhouse where liquid water persists under perpetual twilight. Then there's the climate enigma. A planet this ancient wouldn't just be cooler, it would be evolved. Its star's slow fusion would have gradually brightened over eons, forcing any life to adapt to shifting temperatures or retreat underground. Imagine microbes that first thrived in tropical seas now huddled around geothermal vents, their biochemistry rewritten by necessity, or complex organisms with metabolisms slowed to match the star's fading energy, like trees growing over millennia instead of centuries. The most haunting possibility, Captain B might be a graveyard of lost biology. If life arose here 8 billion years before Earth formed, it could have flourished, then vanished, leaving behind fossilized oceans or oxygen-depleted air as its only epitaph. Future telescopes might hunt for those ghostly fingerprints in its atmosphere, but one thing's certain, this planet isn't just a scientific target. It's a time capsule from an era when the universe was young, and life's first experiments might have already begun. Kepler 438b should be a paradise, a world so similar to Earth in size and temperature that for a brief moment, astronomers dared to call it the most Earth-like planet ever discovered. Located 470 light-years away in the constellation Lyra, this rocky planet orbits snugly within its star's habitable zone, bathing in just enough warmth to theoretically cradle liquid water. With a radius only 12% larger than Earth's and surface temperatures that could mirror our own planet's milder regions, Kepler 438b checks nearly every box for a potentially habitable world. But here's the cruel twist. Its star is a time bomb. Red dwarfs are notorious for their tempers, but Kepler 438 tantrums are catastrophic. Observations reveal flares erupting from its surface with terrifying regularity, some blasting out 10 times the energy of the most violent solar flares ever recorded by Earth. These aren't just bursts of light, Their apocalyptic radiation storms capable of stripping away an entire atmosphere in mere millions of years. Picture an Earth-sized world bombarded by waves of X-rays and ultraviolet radiation, its skies slowly evaporating into space like steam off a boiling pot. Even if Kepler 438b once had oceans, they'd have long since been torn apart molecule by molecule, leaving behind a desiccated husk under a relentless stellar onslaught. Yet the tragedy runs deeper. Unlike planets orbiting common stars, Kepler 438b doesn't get the luxury of a slow decline. Its flares aren't sporadic, they're frequent and ferocious, some doubling the star's brightness in minutes. For any hypothetical life, this would be like trying to nurture a garden in a war zone. The planet's magnetic field, if it has one, would be locked in a perpetual battle against radiation, its defenses wearing thin over eons. Even underground ecosystems, often touted as refuges on hostile worlds, would struggle. The sheer energy of these flares could penetrate miles of rock, sterilizing subterranean havens with brutal efficiency. What makes this world so haunting isn't just its lost potential, it's the reminder that habitable zones aren't enough. A planet can be the right size, the right temperature, and even the right composition, but without a stable star, it's just a mirage. Kepler 438b stands as a cautionary tale in the search for life. Sometimes the universe teases us with perfection, then reveals the fine print too late. Future telescopes might still spy traces of a long-lost atmosphere clinging to this world, ghostly evidence of what could have been. But for now, it's a sobering lesson, a planet that had everything except time. GJ581g might be the most controversial world in the hunt for habitable exoplanets, a planet some astronomers swear exists, while others insist it's just a ghost in the data. Orbiting the dim red dwarf GJ581 20 light-years from Earth, this disputed world first made headlines in 2010 when researchers claimed it sat squarely in the star's habitable zone, with conditions ripe for liquid water. But the excitement quickly collided with skepticism. Follow-up studies failed to confirm its existence, chalking up the initial detection to stellar activity masquerading as a planetary signal. Yet a stubborn faction of scientists still fights for GJ581g's place on the cosmic map, turning it into a modern astronomy mystery. What makes this debate so heated starts with the stakes. If real, GJ581g would be a super-Earth roughly 3 to 4 times our planet's mass, with gravity strong enough to hold onto a thick atmosphere. Its orbit, about 37 Earth days, places it in the habitable zone's sweet spot, where temperatures could allow water to pool without freezing or boiling away. But here's the twist: red dwarfs like GJ581 are notoriously fickle. Their surfaces ripple with star spots and flares, creating noise that can mimic the subtle tug of an orbiting planet. The original team used radial velocity measurements, watching for the star's wobbles caused by gravitational pulls from unseen worlds. They reported not 1, but 6 planets in the system, with GJ581g as the crowning jewel, a potential water world. Critics, though, weren't convinced. Independent analyzers suggested the planet might just be artifacts in the data, fluctuations from the star's own turbulent behavior. Without direct imaging or transits where the planet passes in front of its star, dimming the light, the case rests largely on statistical interpretation. Yet the pro-planet camp counters with refined models, arguing the signal is too consistent to dismiss. They point to GJ581g's predicted equilibrium temperature, which, if it has an Earth-like atmosphere, could hover around -12 degrees Celsius. That's chilly but not impossible for life, especially with greenhouse gases or geothermal heat tipping the scales. The most tantalizing scenario, GJ581g might be tidally locked, one side forever facing its star, the other in endless night. But instead of a frozen wasteland, a thick atmosphere could redistribute heat, creating a twilight belt where temperatures are just right for liquid water. Imagine sprawling glaciers on the dark side feeding rivers that trickle into sunlit valleys, their banks warmed by that perpetual crimson glow. Or perhaps underground aquifers thrive, shielded from surface extremes, much like Earth's subglacial lakes. The controversy isn't just academic, it's a lesson in how messy cosmic discovery can be. GJ581G forces us to confront the limits of our tools, the gaps between what we think we see and what's really out there. Until next-gen telescopes settle the debate, this world lingers in Schrödinger's paradox, both a habitable marvel and a celestial mirage, and that ambiguity is what makes it fascinating. Because whether GJ581G exists or not, it's already done its job pushing astronomers to ask harder questions, dig deeper into the data, and remember that sometimes the universe's most compelling stories are the ones we can't quite prove yet. HD 85512b isn't just another super-Earth, it's a masterclass in atmospheric alchemy. Orbiting a dim orange dwarf 36 light-years away, this world straddles the razor's edge of its star's habitable zone, a cosmic tightrope walk where survival hinges on one critical factor: clouds. At 3.5 times Earth's mass, it's the kind of planet that shouldn't need miracles to stay temperate. Yet here's the puzzle: it receives barely enough starlight to keep water liquid, like a campfire struggling to melt frost on a winter morning. So how does it defy the odds? The answer might be floating right above its surface. What makes this world so fascinating starts with its air. HD 85512b's thick atmosphere, likely a dense shroud of nitrogen and carbon dioxide, acts like a planetary pressure cooker, trapping every scrap of heat its feeble star provides. But the real magic lies in what swirls within that air. Climate models suggest something extraordinary: a permanent overcast, picture global cloud cover so efficient, it reflects just enough starlight to prevent overheating while insulating the surface like a cosmic quilt. These aren't Earth's fleeting cumulus formations, they're high-altitude blankets, possibly made of salt crystals or metallic compounds, engineered by nature to maintain equilibrium. Position is everything here. The planet's orbit 60 Earth days long dances along the habitable zone's outer fringe, where most worlds would be frozen marbles. Yet simulations reveal a tantalizing scenario. With at least 50% cloud coverage, HD 85512b could maintain surface temperatures around a balmy 30 degrees Celsius. That's not just survivable, it's comfortable. Rivers might carve valleys under hazy orange skies, their waters warmed by the very air pressing down with nearly twice Earth's surface pressure. But there's a catch: too many clouds and the planet plunges into an ice age, too few and it becomes a steam bath. The delicate balance depends on something we can't yet see: atmospheric dynamics. Does it have Earth-like jet streams to distribute cloud formations? Or are its weather patterns locked in place by tidal forces, creating permanent cloudy hemispheres and arid deserts? The James Webb Space Telescope might soon crack this enigma by analyzing light filtering through those alien skies. The implications stretch far beyond one world. If HD 85512b proves that cloud regulation can salvage planets on the habitable zone's edge, it means the galaxy's real estate for life just got a lot bigger. Suddenly, stars once written off as too dim become potential hosts, their orbiting worlds redeemed by atmospheres clever enough to compensate. This super-Earth isn't just a candidate for habitability, it's a beacon for the art of the possible, proving that sometimes survival isn't about where you orbit but what you're wearing in your skies. Kepler 296e doesn't just orbit a star, it shares its cosmic neighborhood with 4 other planets, all locked in a delicate gravitational ballet around a dim red dwarf. This 5-planet system, located roughly 1,200 light-years from Earth in the constellation Cygnus, offers a rare glimpse into how multi-world systems behave under the faint glow of one of the galaxy's most common stars. But what makes Kepler 296e stand out isn't just its siblings, it's the uncanny resemblance to our own planet. With a radius just 1.5 times Earth's, it's one of the few exoplanets that feel familiar in scale, a rocky world where gravity would only feel slightly heavier underfoot. The real intrigue lies in its orbit. Kepler 296e completes a full trip around its star every 34 Earth days, placing it squarely in the habitable zone, that magical distance where liquid water could pool on its surface. But here's the catch: habitable zones around red dwarfs are deceptive. These stars are so cool and faint that planets must huddle dangerously close to stay warm, like campers circling a dying fire. For Kepler 296e, that proximity comes with risks. Red dwarfs are notorious for their violent flares, eruptions of radiation that can strip away atmospheres and sterilize surfaces in mere millennia. Yet Kepler 296's relative calm gives scientists hope. Unlike flares from stars like Proxima Centauri, this star's outbursts appear less frequent, offering the planet a fighting chance to hold onto its air and any water that might cling to its surface. Then there's the tidal locking question. Most planets this close to their stars become gravitationally frozen, one side perpetually scorched, the other shrouded in eternal night. But simulations suggest Kepler 296e might dodge that fate. Its orbit could be just eccentric enough, slightly oval rather than perfectly circular, to allow a slow, wobbling rotation. Picture a world where the sun creeps across the sky over weeks or months, dragging daylight with it like a sluggish spotlight. That subtle motion might distribute heat more evenly, preventing the extremes that doom so many other red dwarf planets. The wild card, its atmosphere. Without direct observations, we're left to speculate. If Kepler 296e has a thick shroud of greenhouse gases, say carbon dioxide or methane, it could trap just enough warmth to offset its star's feeble light. Oceans here wouldn't mirror Earth's turquoise vastness. They'd be darker, murkier, absorbing every scrap of that crimson glow. Or perhaps the planet is a Haitian world with global seas beneath a hydrogen-rich sky, where life huddles in the depths, shielded from radiation by miles of water. What makes this system truly fascinating is its complexity. With 5 planets packed into orbits smaller than Mercury's, gravitational nudges are constant. Kepler 296e might experience tidal heating, its interior warmed by the gravitational flexing of its siblings, fueling volcanic activity or even subsurface oceans. Imagine geothermal vents spewing minerals into alien seas, their chemistry enriched by millennia of planetary tremors. The ultimate question isn't just whether Kepler 296e could be habitable, but whether we'll ever know for sure. Current telescopes can't peer into its atmosphere, but future instruments might catch the faint fingerprint of water vapor or ozone. Until then, this world remains a tantalizing what if a reminder that Earth-like size and the right orbit aren't guarantees, but they're a starting point. And in a universe where red dwarfs outnumber sun-like stars 10 to 1, understanding planets like Kepler 296e isn't just academic. It's the key to unlocking whether life's recipe works under dimmer, redder skies. 12 light-years from Earth, practically next door in galactic terms, Lighton B hangs suspended in perpetual twilight, a world caught between fire and ice. Orbiting the red dwarf star Lighton star, this exoplanet weighs in at roughly 3 times Earth's mass, placing it firmly in the super-Earth category. But what truly sets it apart is its precarious position, smack in the middle of its star's habitable zone, a region where liquid water could exist, the catch. This isn't the gentle, sunlit habitable zone we're used to. Lighton B's star is a dim, crimson ember, so faint that the planet must huddle closer than Mercury orbits our sun just to stay warm enough for water to flow. And flow it might. Climate models suggest Lighton B could be a tidal-locked world, one hemisphere forever baked under its star's dull glow, the other plunged into endless night. Yet between these extremes lies possibility. The Terminator line, the razor-thin border between day and night, could host a temperate belt where temperatures hover near melting point. Picture sprawling glaciers on the dark side feeding rivers that trickle into sunlit valleys, their waters steaming under that perpetual cherry-colored sky. Or perhaps the entire dayside is a global ocean, its tides locked in place by gravity, while the night side hides a frozen wilderness capped by towering ice cliffs. But Lytton's star has a temper. Red dwarfs are notorious for their violent flares, and while this one is quieter than most, it still erupts with enough force to strip atmospheres over time. If Lytton B has managed to hold onto its air, likely a thick shroud of nitrogen or carbon dioxide, it's because of two lifelines: its stronger gravity and a potential magnetic field. A planet 3 times Earth's mass could generate a robust magnetic dynamo, deflecting the worst of those stellar tantrums. And if volcanic activity churns beneath its surface, constantly replenishing lost gases, this world might just be clinging to habitability by its fingertips. The real wild card is time. Lytton's star is ancient, meaning this planet has had billions of years longer than Earth to experiment with chemistry. If life exists here, it's had epochs to adapt to the faint light, the crushing gravity, the occasional radiation bath. Maybe organisms here don't rely on photosynthesis at all, but instead harvest energy from geothermal vents or stellar flares themselves. Or perhaps life huddles underground, shielded from the whims of its moody star. What makes Lytton be so compelling isn't just its potential, it's the urgency. At 12 light-years away, it's one of the closest potentially habitable worlds we've found. Future telescopes could soon analyze its atmosphere for water vapor or methane. And if they find them, suddenly, this twilight world becomes more than a scientific curiosity. It becomes a destination, a place where, one day, we might send probes to skim those alien skies or land on those ambiguous shores. Until then, Lytton B lingers in our imaginations, a reminder that the universe's most promising real estate might not look like home at all. Kepler 442b stands as one of the most perplexing gems in the exoplanet catalogue, a world that scores higher on the Earth Similarity Index than almost any other known planet, yet hides its true nature behind layers of cosmic ambiguity. With an ESI rating of 0.84, it outranks fan favorites like Kepler 186f and even TRAPPIST-1e, matching Earth's size, density, and temperature range with uncanny precision. But what does that number really mean? The ESI measures how closely a planet mirrors Earth in key categories: radius, density, escape velocity, and surface temperature, but it can't tell us about the intangibles, the chemistry of its air, the turbulence of its star, or the whispers of biology that might lurk beneath its skies. What sets Kepler 442b apart isn't just the stats, it's the light. Unlike planets orbiting chaotic red dwarfs, this world basks under the steady glow of a K-type star, slightly cooler and dimmer than our Sun but remarkably stable. That star emits a spectrum of light skewed toward red and infrared wavelengths, a feature that could turbocharge photosynthesis if plant-like organisms evolved here. Leaves under that amber sky might appear deep violet or black, optimized to absorb every photon of that crimson-rich radiation. But the star's age adds another layer of intrigue. It's billions of years older than our Sun, meaning any life here has had a colossal head start to refine its survival strategies. The real test lies in the atmosphere. Future telescopes like the Habitable Worlds Observatory, slated for the 2030s, could analyze the chemical fingerprints of Kepler 442b's skies with unprecedented clarity. Imagine detecting oxygen in a pattern that defies geological explanations, or methane spikes that sync with seasonal changes, hints that something active is altering the air. But biosignatures are never simple. Oxygen can accumulate from non-biological processes like water molecules splitting under starlight. Methane might seep from volcanic vents. The smoking gun, a combination of gases out of equilibrium, like oxygen and methane coexisting, a mixture Earth's microbes maintain through constant metabolic activity. Kepler 442b's true potential may hinge on its geology. A planet this size likely has active plate tectonics, recycling nutrients and stabilizing its climate over eons. Subsurface water could interact with mineral-rich crust, creating hydrothermal oases akin to Earth's lost city vents, where life thrives without sunlight, powered by chemistry alone. Or perhaps it's a world of shallow seas and sprawling continents, where tides sculpt coastlines under a sun that never scorches, only ever glows. The irony. For all its promise, Kepler 442b remains a silhouette against its star. Until we glimpse its atmosphere, it's both a frontrunner in the search for life and a cosmic Rorschach test projecting our hopes onto the data. But that's the thrill of exoplanet science. Every Earth-like label is a starting point, not a conclusion. And as telescopes grow sharper, this distant world might reveal the most humbling truth of all. That habitability isn't a checklist but a spectrum, and we've only just begun to read it. What a journey it's been, 25 worlds, each a testament to the universe's boundless creativity. From the molten glow of super-Earths to the icy twilight of tidally locked ocean planets, we've wandered across cosmic landscapes that defy imagination yet whisper tantalizing possibilities. These aren't just dots on a star map, they're invitations to rethink what habitable even means. Kepler 186f's amber-lit valleys, Proxima b's razor-thin twilight belt, K218b's glowing, fluid oceans, every discovery stretches the boundaries of where life might cling, adapt, even thrive. But here's the humbling truth, we've barely scratched the surface. For every planet we've catalogued, there are billions more waiting in the dark, each with its own story. The search for life isn't just about finding Earth twins, it's about uncovering the universe's flexibility. Could biology blossom in the crushing depths of a mini Neptune? Flourish under the flickering glare of a flare star? The more we learn, the clearer it becomes. Life, if it's out there, won't follow our script, it'll surprise us. And that's why this search matters. Every new telescope, every atmospheric analysis, every flicker of data is a step toward answering humanity's oldest question: are we alone? The JWST glimpses of water vapor, the tantalizing whiff of dimethyl sulfide on distant worlds, these aren't just headlines. They're clues in a galactic detective story, one where the next breakthrough could come tomorrow or a century from now. So stay curious, because the hunt for exoplanets isn't winding down. It's accelerating. Missions like the Habitable Worlds Observatory and the extremely large telescope promise to bring these alien skies into focus like never before. Who knows, the planet that finally answers the life question might already be hiding in our data, waiting for a keen eye to spot it. Or it might be orbiting some nameless star, its secrets still veiled by distance and time. One thing's certain, the cosmos isn't just vast, it's alive with possibility. And as long as there are stars to scan and mysteries to unravel, the story of these worlds and our place among them is only just beginning. Keep looking up, the next chapter is yours to discover.